Hi, welcome to lesson 15 in the series of 8051 microcontroller programming and interfacing. For more information, you can visit us at www.jcbrolabs.org. In this lesson, we will talk about some of the basics of stepper motor, and we will also learn how to interface the stepper motor to 8051 microcontroller. So in our previous lessons, we have talked about the interfacing of DC motor. So DC motor is a very simple case, which we just connect power supply and it starts running. While in the case of stepper motor, it has a special kind of, we can say, DC motor. Special kind of DC motor. That means it runs in a step. So whenever there is a requirement of a precision rotation, like we want a rotation of 45 degree or for say 15 degree, then we use this kind of motor, stepper motor. So this stepper motor rotate in several steps. So if we talk about first, let's talk about the kinds of stepper motors. So there are mainly two kinds of stepper motor. Those are unipolar stepper motor and bipolar stepper motor. So the difference between these two can be visualized from this figure. This bipolar stepper motor has 4 wires. So these are the two different windings, and total wires coming out for this motor are 4. While in the case of unipolar stepper motor, there are 5 wires and 4 for winding and 1 for common. So at the common we can connect a power supply. So first steps comes to the interfacing of DC motor, or to how to run this stepper motor. So if we talk about unipolar stepper motor, if a motor is unipolar stepper motor, that means there are 5 wires which are coming out. It can be interfaced with ULN2003 IC. While if our stepper motor is bipolar, that means only 4 wires are coming out from the stepper motor. We need L293D or any other H-bridge based driver circuitry to run the DC motor. So let's have a look on the kind of motors which we have at our end, and which we'll be using for in this video. So this is one kind of stepper motor, as we have discussed. Here we have two different stepper motor available to us. One is unipolar and one is bipolar stepper motor. So the difference between this unipolar and bipolar stepper motor can be made by the number of leads which are coming out from this stepper motor. So as we can see, in this stepper motor there are 4 different wires. So this is a bipolar stepper motor, and we need a different driver circuit based on L293D IC, like this one which we have made for stepper motor, and we have connected one stepper motor to it. So this driver circuit, this unipolar, this bipolar stepper motor use this L293D based driver circuit to run. While here we have another kind of stepper motor, and it has 5 wires coming out of it. So it is a unipolar stepper motor. There are 2 wires for one winding and 2 another wires for another winding. This middle one wire is a common wire, and it is used for providing power supply to this unipolar stepper motor. So for this unipolar stepper motor we need a different kind of driver IC, and here that is driver IC. This is ULN2003. This unipolar stepper motor can be interfaced or can be driven with the help of this ULN2003 IC. The only thing which needs to be done is to connect this common wire to plus 12 volt or plus 5 volt power supply depending on the kind of requirement, and then remaining 4 wire can be connected to this ULN2003 output pins, and the input ULN2003 IC can be come from this microcontroller. So let's back to theory classes and learn how to write a program to run this particular stepper motor in stepwise. So you have seen the kinds of stepper motor, unipolar and bipolar, and the basic difference between these two can be the identification of these two can be done by the number of wires which are coming out from these stepper motors. Now when we talk about running of this stepper motor, as we say, it runs in a steps. That means when power supply is connected, so every manufacturer define the step angle to the of these stepper motors. So it is basically based on the manufacturing. So if we say we have 0.72 degree angle, that means in first step, in single step, it will rotate by 0.72 degree, or it could be 1.8 or it could be 15. So depending on the kind of motors, these angles can vary. And so if we want to rotate a complete 360 degree, that means we want to make a complete one revolution. So the number of steps which will be required here will be 500, and for 1.8 case it will be simply 200. So this is very simple, just divide this angle by this step angle and it will comes out to this one. And if this 15, then we need simply the 24 steps. So we talked about steps, we talked about step angle. So now next thing which we'll talk about, like how to do how to apply a step. So when we say we have applied a single step, that means we talk about our voltages which have been applied to the windings. So in our case we will be interfacing this unipolar stepper motor. So let's first let's have a diagram of stepper motor and things about like what are the pins of which we are concerning with. So these two pins are common, that means this will be connected to plus 5 or plus 12 volt, and this is A, this is B, this is C, and this is D. So when we talk about applying a step, so applying a step means the combinations of ones and zeros which have been applied to these motors. So there are several ways for applying the step sequence. First is 4-step sequence. 4-step sequence means if we apply a voltage in this sequence, the rotor or the rotor of the motor will rotate by one step. That means we have A, winding B, winding C, and winding D. So if we applied 1 0 0 1, that means 1 0 and 0 1. This this motor will rotate by 1 degree in clockwise direction. This is clockwise and the upper one will be anti-clockwise direction. So now just shift this entire sequence, apply 1 1 0 0, this will rotate further in the same direction, and similarly 0 1 1 0, and then 0 0 1 1. So and then repeat it. So in order to repeat it, it will continuously rotating. So if we apply single step, the motor will rotate by 1 step angle. That means if the angle or the step angle of this stepper motor is 7.5 degree, then it will rotate by 7.5 degree in single step. Then for next step it will rotate by another 7.5 degree, then another 7.5 and another 7.5. So complete 4 step sequence it will rotate by 30 degree. So based on that we can arrange a sequence by which we can rotate this stepper motor at any specific angle. So next things comes let's take a simple case in which we need to do simplest calculations. The question is we need to rotate or write a program to rotate by 64 degree. So we need to rotate by 64 degree and the step angle is of 2 degree. So we will calculate the number of steps which will be required. So steps will be number of steps will be required. Okay, so we have 4 step sequence and total number of steps required for making this total steps for making by 64 degree will be a one step take 32 degree, so there will be total 32 steps will be required. And okay, so total 32 steps will be required, and further because we have a 4 step sequence, so we need total 8 repetition of these 4 steps. 8 repetition of 4 steps. Now let's have one again. We need to rotate it by 64 degree. One step angle is 2 degree. It is the motor specification. So we need total 32 steps to rotate by 64 degree. Now we have 4 step sequence. That means these 4 commands which we just saw, like 1001, 1100, 0110 and 0011. These are the 4 sequence. So this 4 sequence makes a complete set. So further divide this 32 by 4. So we'll need 8 times of this. We need to repeat these 4 steps 8 times. So if we write this program, then our motor will be rotated by 64 degree. Similarly, this 4 step sequence was for rotating in a single step. Similarly, there is another way also to make or to do more precise operation, that is half step sequence. Half step sequence means on one sequence motor will rotate by half step angle. So this is known as half step sequence. So in this half step sequence there will be total 8 combinations by which we can rotate our stepper motor, and by one step our stepper motor will rotate by half an angle. So it is 1001, then 1000, then 1100, then 0100, and then 0110, then 0010, then 0011, and last 0001. So again this is our this direction is our clockwise direction and this direction is our anti-clockwise. That means If we first give this step then this step, it will run it clockwise, and if we first give this and then this, motor will rotate in anti-clockwise direction. So this is how some of the basic of a stepper motor, and this is how our stepper motor works. Now let's make a connections for operating or for connecting like a unipolar stepper motor to or in order to make a connection to interface a unipolar stepper motor to 8051 microcontroller. So the thing is, we will be having a 8051 microcontroller here, and we will be using 4-step sequence. So out of this 4-step sequence, we will connect this 1.0, 1.1, 1.2 and 1.3, and then we will be having, as we have just discussed, ULN 2003 is used to interface this unipolar motor, and this is ground, and this is pin number 1, pin number 2, pin number 3, pin number 4 of ULN 2003, and then there are 4 pins of this ULN 2003, A, B, C and then D. So, and this is 15, 16 pin number, 15 and then 14 and then 13, and these are the pins of the windings or of the stepper motor. So here we have a stepper motor winding. So this is stepper motor, and one of the pin of this stepper motor is connected to plus 12 or plus 5 volt as per the rating of this stepper motor. So this is the common pin of the stepper motor, or generally it is the middle pin. If it is there are 5 leads, then it is the middle wire which is common and which needs to be connected to 12. So this is our connections. The connections are very simple. Now let's write a program in embedded C on Keel in order to interface a stepper motor. Open Keel. Now create a new project. And let's make a step, and let's select this 89S52 microcontroller, and then save it with a .c, and then add files to this group. Okay, and then go to manage. We have already done this, manage options, and make this output create hex file. Writing a program is very easy, as we'll see. So include reg52.h and then provide that one a signature for delay function. So it is again same as we have discussed in so many programs. Void main void, and then void delay unsigned int t, and then unsigned int I comma j for I equals to 0 to I is less than 1, I is less than t, and then I plus plus, then for j equals to 0 to j is less than 1275, and then j plus plus. Now because we will write a simple program to run the motor continuously in 300 60 revolution. So we'll make it while 1, and then we just apply a 4-step sequence to this one. So our stepper motor is connected to this one, port 1. So let's say P1 is equals to, yes, P1 is equals to 0x 09. So this is the first step, 0x09. Then we also have connected some of the LEDs to port 2. So this is very good practice for the debugging purpose and to understand, to verify whether our program is working fine or not, and we are doing in hardware. So depending on this delay, you can change the speed of the stepper motor. If this delay is high, you can visualize the stepper motor taking small steps, and then P1 is equals to 0x 03, and then again P2, let's send some other command, and then delay, and then P1 is equals to 0x 06, and then P2 equals to 0x 0f, and then delay 20, then P1 is to 0x 0c, and then P2 is equals to 0x 0f0, and then again delay. Now let's compile it and see. Okay, it's done. Now let's have prior to burning this hex file onto the hardware, let's see whether it is running on this simulator or not. So let's take 89C51, yeah. And then let's have, so as we have discussed, we don't need okay, let's say we have ULN 2003. So let's rotate it and can make the connections. And then let's have a stepper motor. So we are having unipolar stepper motor. Okay, so this is our unipolar stepper motor, and the connections are like this one, and then this, and then this, and this. We can set the step sequence, so step angle, let's say we are having a 15 step sequence, and then we should terminal, first is ground, and then let's have terminal for power, okay, and let's change this one, hex code. Wait a minute, step.hex. Yes, this is the one. Open. Okay, now let's So the connections are wrong, so it is just rotating. So this needs to be checked whether connections are properly placed or not. So generally it is not mentioned like which one is this A and which one is B. So in a hardware it is directly in a sequence, but in simulations it takes let's hope. We know still okay, this one is also needs to be connected to power supply. Wait, it is not rotating at all. Is let's see. Let's connect this one and then let's have a look. Okay, it's not given here. And connections are wrong, so you can try it and then we can have different connections. Generally okay, let's have a different motor at all. Let's say we have a bipolar. Now you can see it's rotating, so it is taking some steps and then it is making complete revolution. So similarly you can also do on the previous one. So that means our code is working, and now let's burn the program on the hardware. So let's open the programmer and connect and then erase chip and then open hex and select the hex file and then simply upload it. So let's wait for some time and so this stepper motor finds several applications very precise rotation is needed, like in printers, in CD drivers, and you can imagine even in hard disk. Everywhere these stepper motors finds application for automatic antenna alignment, and there are several ways for using it. The more step angle is there, that means the more the number of and the step angle of this motor depends on the number of teeth on the rotors. So the more number of teeth on the rotor are, the more precise rotation this stepper motor can take. So programming is nearly done. Okay, it's done. So now let's have a look on the hardware, how the motor is run. So this is our programmer, or the Arduino, which is used to program this 89S52 microcontroller. So we have burned the program into this IC, and here we have LEDs. These LEDs are running at very fast, so camera can't capture the blinking ray. Now, as we have seen in programming, the port 1, the 4 pins of the port 1 are used to provide the sequence to the stepper motor, 4 pins. So these 4 pins of this port 1 are connected to the here to ULN2003 IC, and these are the 4 pins. The output 4 pins of this ULN2003 are further connected to the this stepper motor here. This stepper motor, and now right now this stepper motor is running, but due to some arrangement you may not be able to visualize it. The program which we have written, it is sending continuously this 4-step sequence. So this motor is running like a normal motor in normal rotations. So if this can be visualized, yes, it is rotating continuously in full revolution mode. So this is how we can make this stepper motor run, and further we will learn how to rotate this stepper motor in a specific angle, or for say like okay, only it should rotate only 45° or 64°. So we will write that program just now, and then we'll see it. So you have seen how to interface a stepper motor with 8051 microcontroller and using embedded C language. So I hope in upcoming video, or on our another another YouTube page, we will try to make a small program for rotating this stepper motor at any specific angle, like for 64°, for 15°, or for 13°. So that's it for this video. Thank you.